So good morning again from my side, and here I will briefly present a general overview of extreme events in the past and current period on a global level and Europe, especially focusing on heavy precipitation, and also I will show some results of the activities carried out within the TRANS-ALP project in collaboration with the colleagues. So first of all, an extreme event needs to be defined, and this is not an easy and trivial task. So the IPCC defined an extreme as an event that is rare at a particular place and time of year. However, we have different ways to define the rarity of an event. And one of the most common approaches to define rare conditions is to detect those conditions that are above or below a certain threshold. Then we also have to include as extreme events, very different processes. So we have extreme temperatures, heavy precipitation, floods, droughts, storms, and so on. And all these events occurred in different scales, spatial and temporal scales. However, once we define we establish a definition of the extreme that we want to study, we can quantify this event by measuring some specific properties of the process. So, for instance, we can check the frequency of the event in a specific time frame, the intensity, duration, and so on. The study of extreme is, of course, particularly relevant in a changing climate. Changes, this is just the example for temperature, however, changes in mean climate conditions, as well as changes in the variability, climate variability, and changes in the shape of the distribution could lead to changes in the extreme conditions. So the extremes could become more or less frequent. We can have unseen events. We can have changes in the spatial pattern, the extent of the events, or changes in duration, timing, and so on. And actually, we all know that the global mean temperature has already increased of slightly more than 1 degree, starting from the end of this century, of the 19th century, and with a further acceleration in the warming over the last decades. In the latest report of the IPCC, as was previously mentioned, they clearly state that human-induced climate change is affecting lots of extremes in every region across the globe. And we have evidences of these changes from observations, and also their attribution to the human influence has strengthened since the previous version of the report. If we focus, for instance, on heavy precipitation, observations that are available from all over from different countries in the world show that we have a significant increase of heavy precipitation, especially in this simplified representation of global countries. We have an increase of heavy precipitation in Europe, Asia, and Northern America, while the signal is more uncertain in the other areas, and this is also largely due to the lack of sufficient data and study available. However, at a global scale, the rising temperatures are expected to lead to an increase in the water vapor content in the atmosphere through the Clapeyron relation of more or less 7% of increase per degree of warming. The increase in the water vapor content leads to an increase of intense precipitation at a similar rate. This is at a global scale. However, to this thermodynamic effect, we have to include also the dynamic changes, and these dynamic changes lead to stronger differences in the precipitation changes on a regional level. So if we focus on Europe, we have several studies that assess the recent trends in heavy precipitation on a European level and in European subregions. And so, for instance, Mire et al. Show that we have an increase in the precipitation exceeding the 1990s percentile, especially in Northern Europe, based on observation in the most recent decades with respect to the beginning of the 20th century. And they also show that there is a change in precipitation distribution that lead to an increase in the frequency and intensity of the events. Similarly, other studies show that in a large portion of Central Europe, we have an intensification of the intense precipitation events over the last century, with a positive scaling with the Northern Hemisphere temperature anomalies. And also other similar findings were found for other subregions. So, for instance, for Switzerland, with an intensification of the events and also an increase in frequency. So within the TRANS-ALP project, we defined an approach to detect and characterize the most relevant intense heavy precipitation events in the last decades in a transboundary area covering Austria and Trentino-South Tyrol. And to do this, we used some gridded data sets of daily precipitation at 1 kilometer resolution derived from observations. So more specifically, we used Spartacus for Austria, generated by ZAMP, and a gridded data set for Trentino-South Tyrol, generated by Eurac. The common period starts in 1980, so we consider the last 40 years for the analysis. So here we adopted two types of approach. Approaches. The first one aims at identify larger scale events, and in that case we selected those days over the 40-year periods where we have accumulated area precipitation over the entire area above the 1990 percentile of the daily cumulated values, aerial values over the 40-year period. The second approach wants to select smaller scale events, and in that case, we computed the 1990th percentile spatially for each day of this 40-year record, and then we selected those dates that are associated to that show the highest 1990th percentile. So at the end, we have lists of events for Trentino, South Tyrol, and Austria, and we selected those dates, those highest ranking dates, in order to analyze and characterize the most meaningful events in those 30-year record. So first of all, if we order in a chronological way, the most relevant events identified, we see that most of them are concentrated in the most recent years. And it's also interesting to know that all the identified events were also associated to observed and recorded impacts in the area. So once we have this list of heavy precipitation events, we could also characterize them. So for instance, we check the seasonal dependence of those events, the frequency over the years, as well as the intensity distribution of all these events. And we see, for instance, that findings are quite similar between Trentino, South Tyrol, and Austria, for instance, with a more pronounced occurrence of events, of heavy precipitation events in the autumn period. This is what's similar to what I showed before, but if we put in that case all small scale events that we identified and we compare them with the year of occurrence, so here we have the intensity of the events, and here on the y-axis the year of occurrence, we see that the most intense events in both areas occurred in the recent years of the series. As I said before, one of the aims of this approach was to to find an easy method to detect intense precipitation events in the past, and also to provide a tool to characterize in a spatially explicit way these events. So for each event, we produced, besides the intensity maps, also anomaly maps. And the anomalies were defined as the ratio of the daily precipitation during the event and the long-term mean monthly precipitation for the corresponding month. In that way, we can use the anomalies to assess at which extent an event can be considered as exceptional. And we can also find a good way to compare events that occurred in different areas, so with different climatic conditions and also in different seasons. Since, as I said before, with extreme events, we are not referring only to heavy precipitation, but of course we have different phenomena. Within the TRANS-ALP project, we also try to find a method to detect and characterize the extreme wind speed event in the past, and also to assess if available data are suitable to characterize those events. So in that case, we used area analysis data, so model data. This Cosmo 6 at 6 kilometer resolution and covering slightly less than 30 years. The extreme event was defined as the day in which the maximum wind speed exceeds the 1990s percentile. And here, as before, we applied this method to two areas, one in Austria and one as Trentino South Tyrol, and then we try to characterize the identified events in terms, for instance, of the frequency distribution for different seasons and also the intensity distribution for different seasons. We see that there are some similar findings between the two areas, with a more pronounced occurrence of events in Austria during autumn for the Austria area. However, if we compare the model data with observations, and this is just an example with a station where we have enough data available, we see that the model data systematically underestimate maximum wind speed values. And these discrepancies also lead to different results in the return period associated to the recorded events. So this suggests that these potential discrepancies between model and observations need to be carefully taken into account when these products are used for the characterization of wind precipitation events at a local scale, on a local scale. So far, we talked only about the past and current period, but as was also mentioned in the introduction, heavy precipitation are projected to increase in intensity and frequency, especially in Northern and Central Europe, as also shown, for instance, in the results in the report provided by the European Environmental Agency last year. But if we consider the projections also on a regional scale, this is just an example for Trentino South Tyrol, we also have potential possible increase of heavy precipitation and in frequency of them. And also, again, based on this regional projections, if we performed a generalized extreme value analysis in the historical period and in the future period, we see that we have changes in the shape parameter of the distribution. The shape parameter is related to the tails of the distributions. So a higher shape value means longer days, and we see here that we have a change towards more positive values in the future of this shape parameter. So just to conclude, we have evidences of increasing of heavy precipitation events in Europe, even though the signal is heterogeneous on a local level. The findings from the observation of the project and the TRANS-ALP project can support the detection and characterization of the past heavy precipitation events, and also help to analyze those events and associate them with impacts. This threshold-based analysis and method could also be helpful for the identification of the past extreme wind events in the area, but we need to take into account that in the characterization that there are still challenges and discrepancies between observations and models. Since we are expecting a further increase of extremes in the future, it is extremely important to investigate further these changes, and this is what will be done in the next session. So thank you all for the attention, and that's it.